4 hours ago, something happened that should not be possible. On February 21st, 2026, the Atacama Large Millimeter Array in Chile detected a signal from 3I Atlas that has less than a 0.002% chance of occurring in a natural comet. Let that sink in. This was not water vapor, not frozen nitrogen, not drifting dust. The signal was ionized calcium, Ca2, the same element that strengthens your bones, the same element that allows your heart to beat and your neurons to fire, is now being blasted into space by an object drifting 240 million kilometers away. Picture a frozen rock in deep space, surrounded by darkness, far from the warmth of the Sunday. Now imagine that object suddenly ejecting a massive, focused plume of the very material that makes up your skeleton. In standard comet science, this is impossible. Comets are often described as dirty snowballs, leftovers from the birth of our solar system, made of frozen gases and silicate dust. They do not behave like furnaces. They do not generate plasma. To strip electrons from calcium atoms and turn them into ions requires enormous energy. We are talking about temperatures near 6,000 degrees Kelvin, comparable to the surface of the Sunday, yet 3I Atlas is currently sitting in a region where the ambient temperature is roughly minus 100 degrees Celsius. It is far from the Sunday, it shows no internal heat source, and still, at 8:15 Eastern Standard Time, NASA's Deep Space Network recorded an unmistakable spike, heavy ionized calcium, released in massive quantities. If you placed a block of ice in your freezer and it suddenly began glowing white, hot, and spraying molten metal, you would not call that normal. You would question the laws of physics, or you would question whether the object was truly ice at all. That is where we stand with 3I Atlas. When the data first came in from ALMA, the immediate assumption was error, a calibration glitch, a background interference. But then independent verification began. ESA's Gaia mission cross-referenced the data from a different angle. The Hubble Space Telescope aimed its wide-field camera 3 at the object. 3 independent instruments, 3 different methodologies. The same conclusion. The calcium is real, and it is not drifting randomly. It is forming a directed jet. Thousands of tons of ionized material ejected within hours. In a natural outgassing event, you would expect a messy spherical cloud of dust. Instead, we see a focused stream. The implications are enormous. If an interstellar object is ejecting biological building blocks in a controlled way, the history of life in our galaxy may need to be rewritten. To understand why scientists are unsettled today, we need to look back. 3I Atlas was first identified weeks ago as an interstellar visitor similar to Oumuamua and Borisov. At first, it behaved exactly as expected, cold, dark, inactive. Then, 48 hours ago, the first anomaly appeared, and this is where the story shifts from astronomy to something that looks uncomfortably like engineering. The Keck Observatory in Hawaii first detected it. On February 19th at 3 UTC, the Keck 2 telescope was conducting routine spectral analysis. Astronomers expected faint traces of hydrogen, perhaps carbon or nitrogen ice. Instead, the spectrograph lit up with 2 precise absorption lines at 393.3 and 396.8 nanometers. Anyone familiar with astrophysics knows these numbers. They are the H and K lines of singly ionized calcium. These lines belong in the violent atmospheres of stars, not in a frozen rock drifting between Mars and Jupiter. The rational response was to assume interference from a background star. That was the logical explanation, but the data refused to cooperate with that assumption. And what came next would only deepen the mystery. But the interference explanation collapsed almost immediately. NASA's James Webb Space Telescope redirected its NIRSPEC instrument toward the object, while ESA's Gaia mission locked onto its trajectory with billion-pixel precision. At the same time, the Very Large Telescope in Chile used its espresso spectrograph to run an independent scan. 3 separate observatories, 3 different technologies, 1 identical result. The calcium signature was confirmed with a signal-to-noise ratio of 50:1. That is not background noise. That is certainty. Gaia also detected a measurable brightening of the object, a magnitude shift consistent with a significant release of material. This was not subtle. This was active, and that was only the first anomaly. As researchers examined the spectral data more closely, something even stranger emerged. The calcium was almost pure. In a natural comet, if you somehow heated the surface enough to release minerals, you would expect a mix. Calcium would appear alongside silicon, magnesium, iron, and oxygen, a chaotic blend like a smoothie of cosmic debris. Instead, 3I, Atlas, showed calcium dominating the spectrum at nearly 90% purity. That detail changes everything. Calcium in nature bonds easily with oxygen to form lime or with carbon to form chalk. It does not exist freely in high concentration. To isolate it requires separation, refinement, a process. Finding a cloud of nearly pure ionized calcium around a comet is like discovering refined aluminum bars sitting in a forest. Nature does not refine metals to that degree in open space. Then came anomaly number 3, velocity. When comets warm, gases sublimate and drift off gently at a few hundred meters per second. The calcium ions from 3I Atlas were not drifting. Doppler analysis showed they were accelerating at 40 kilometers per second, that is over 89,000 miles per hour. This is not passive evaporation. This resembles exhaust from an engine. When you combine impossible ionization, unexplained purity, and hypersonic velocity, the image shifts. We are no longer observing a melting rock. We are witnessing an active event. If a mountain on Earth began shooting refined calcium at extreme speeds, you would not call it geology. You would suspect a system inside the mountain producing it. Scientists value evidence over belief. So we asked a simple question. What known natural process can extract calcium from rock, refine it to near purity, ionize it without heat, and eject it at 40 kilometers per second in deep, cold space? Conventional comet models failed. Outgassing cannot account for the required energy. Ionizing calcium demands high-energy photons or extreme heat. Thermal imaging shows the object is cold, no internal reactor, no solar flare, no visible radiation source. Then another pattern appeared. The calcium stream was not continuous, it was pulsing, turning on and off with precise timing. Every 4 hours and 12 minutes, another burst, regular, predictable. Nature is chaotic. Explosions do not run on schedules. Yet 3I Atlas appeared to follow a clock. At this point, we were asking the wrong question. It was no longer, how is a comet doing this? It became, why is an object releasing tons of biologically significant material into our solar system? Energy cannot appear from nothing. That is thermodynamics. To ionize calcium requires 6.11 electron volts per atom. Multiply that by thousands of tons, and the energy output resembles that of a small nuclear reactor. A cold object in the asteroid belt was behaving like a power plant. And as the afternoon progressed, the mystery deepened further, because at 14 UTC on February 20th, the ionization stream changed in a way no one expected. The calcium was not only pulsing in bursts, it was being modulated at a specific frequency that would send shock waves through the astronomical community. The modulation frequency was 1,420 megahertz. For anyone familiar with radio astronomy, that number is not random. It is the hydrogen line, the universal frequency long monitored by SETI as the most logical channel for interstellar communication. Against cosmic background noise, 1,420 megahertz stands out like a lighthouse beam. The calcium ions from 3I, Atlas, were oscillating at exactly that frequency. Imagine discovering a natural geyser erupting in Yellowstone. That is normal. Now imagine that geyser suddenly erupting in Morse code. That changes the conversation entirely. The first assumption was terrestrial interference, stray radio waves from Earth. But Doppler analysis showed the signal shifted perfectly with the object's motion. The modulation was coming from 3I, Atlas itself. Now we had a cold body with no visible power source, generating ionized plasma and modulating it at a frequency associated with intelligent signaling. And the data continued to grow stranger. Spectroscopic analysis revealed that the calcium being ejected was overwhelmingly calcium 40, with isotopic purity reaching 99.9%. On Earth, calcium exists in multiple isotopes. Their ratios act as fingerprints, tracing their origin to ancient supernovae. In any natural sample, heavier isotopes should make up at least several percent. They were absent. Achieving 99.9% isotopic purity requires separation by mass, typically through centrifuges. Nature does not construct centrifuges inside comets. Isotopic refinement to that degree implies industrial processing. Now combine the elements. Impossible energy source, communication, linked modulation, and isotopic purification. The uncomfortable possibility emerged that this was a controlled release. But for what purpose? One theory suggested propulsion. Ion drives on human spacecraft use ionized gases to generate thrust. The 40 km/s velocity supports that idea. Yet trajectory tracking introduced another contradiction. According to NASA's Jet Propulsion Laboratory, 3I, Atlas, was not accelerating away from the jet as Newton's third law predicts. It was accelerating toward it. For every action, there should be an equal and opposite reaction. If calcium was expelled one way, the object should recoil the other way. It did not. This violates conservation of momentum unless the visible jet is not the propulsion system. Perhaps it is exhaust from something pulling the object forward, a gravitational interaction, a magnetic mechanism. No clear answer exists. By noon on February 21st, all of this had been documented. Triple verified spectral data, isotopic analysis, modulation frequency, momentum anomaly. The conclusion was growing difficult to avoid. 3I, Atlas, did not behave like inert rock. It behaved like a system. Then, at 1:45 p.m. Eastern Standard Time, ALMA detected something that changed the discussion completely. Until that moment, scientists debated how a comet could refine calcium. Now the question became why. ALMA's Band 7 receivers identified a secondary signal embedded in the calcium stream. It was not just ions, it was a structured molecular lattice. Specifically, traces of hydroxyapatite were detected. Hydroxyapatite is the primary mineral component of vertebrate bone and teeth. Its chemical structure forms the rigid scaffold of skeletal life on Earth. Finding elemental calcium is extraordinary. Finding hydroxyapatite organized in crystalline form in deep space approaches statistical impossibility. The probability of that structure forming randomly on a comet's surface is roughly 1 in 10 to the 50th power. For practical purposes, 0. Nature does not assemble bone crystals by accident in a vacuum, biology does, and the lattice structure detected matched the biological version found in living organisms, not the geological form found in ordinary rock. That distinction matters. The implications were immediate and unsettling. If natural, we have uncovered a geological process that perfectly mimics life. If artificial, 3i, Atlas, is ejecting the structural foundation of skeletons. And if biological, something inside that object is alive or once was. But the final piece of the puzzle would make this far more urgent. Trajectory analysis from NASA's Jet Propulsion Laboratory revealed that the ejection vector of this calcium-rich stream, now confirmed to contain hydroxyapatite, is aligned directly with Earth's orbital path. In 14 days, our planet will pass through that stream. This is no longer a distant astronomical curiosity, it is an approaching encounter. Let us establish what we know with certainty. First, 3i. Atlas is ejecting ionized calcium, 40 at 40 kilometers per second. Second, the energy required for that ionization does not exist on the object according to thermal readings. Third, the material includes hydroxyapatite in its biological crystalline form, a structure with virtually zero probability of forming naturally in space. Fourth, the ejection vector intersects Earth's orbit in exactly 2 weeks. These are not speculations. These are measurements recorded by the most advanced instruments ever built. The question scientific reports hesitate to phrase directly is whether this constitutes a message. If the phenomenon is natural, it demands a rewrite of thermodynamics. If artificial, it implies engineering beyond our civilization. If biological, it suggests seeding. A directed dispersal of skeletal precursor material into a planetary system. As the stream crosses space, detectors remain focused, the particle cloud is expanding, yet its direction remains precise. Earth will move through it in 336 hours. We will sample the dust. We will test the molecules. And answers will begin to emerge. Yet there is another layer. The pulsing interval of 4 hours and 12 minutes has remained consistent. That timing does not drift. It does not degrade. It behaves like regulation. In engineered systems, pulsing controls output, stabilizes energy flow, or transmits encoded information. Some researchers have begun analyzing whether the 1,420 MHz modulation contains structured patterns beyond simple oscillation. Preliminary Fourier analysis suggests periodic variations nested within the main frequency. It is too early to call it data. But it is not random noise. The energy discrepancy also remains unresolved. To produce thousands of tons of ionized calcium requires power output comparable to a small reactor. No infrared imaging indicates internal heating. No gamma-ray bursts suggest nuclear activity. Yet the output persists. One possibility being discussed quietly is that the energy source is external. Perhaps 3i, Atlas is interacting with a field we do not yet measure. Another proposes advanced magnetohydrodynamic processes. Both stretch current understanding. And then there is the biological interpretation. Calcium is not just structural. In living organisms, calcium ions act as signaling molecules. They trigger muscle contraction, regulate neurotransmitter release, and coordinate cellular responses. The material being released is not inert dust. It is biologically meaningful. Is the object dispersing raw ingredients for skeletal formation? Is it contaminating, preparing, or communicating through matter rather than radio waves? In science, extraordinary claims require extraordinary evidence. Right now, we have extraordinary data. What we lack is explanation. The coming days will be decisive. As Earth approaches the projected intersection point, satellites and ground-based observatories are preparing collection protocols. High-altitude aircraft may sample upper atmosphere particles if density allows. There is calm professionalism in the official briefings, yet beneath that calm lies recognition that we are observing something without precedent. Interstellar visitors have passed before. None have behaved this way. If 3I Atlas is a natural object, then nature is capable of processes we have never imagined. If it is not natural, then humanity has just detected the first evidence of directed material transmission across interstellar space. Either possibility reshapes our understanding of our place in the cosmos. As Earth continues along its orbit, the clock is counting down. 14 days is not long in astronomical terms, but it is enough time for the global scientific community to prepare. The next phase will not rely solely on telescopes. It will rely on direct sampling. And when that moment arrives, speculation will give way to measurement. As preparations intensify, laboratories across the world are aligning instruments for rapid analysis. Spectrometers are being calibrated for isotopic confirmation. Electron microscopes stand ready to examine lattice structures at the nanoscale. If even microscopic traces of hydroxyapatite enter Earth's upper atmosphere, they will be detected. The projected density of the particle stream remains low. No threat to planetary safety has been identified. This is not an impact event. It is a dust encounter. But composition matters more than mass. If the particles retain their ionized state upon arrival, they may interact with Earth's magnetosphere, producing measurable signatures. There is also discussion of whether biological compatibility exists. Hydroxyapatite alone is not life. It is a mineral scaffold. Yet its presence in biologically precise crystalline form raises questions about origin. Did this structure form within a living system elsewhere, or does some unknown process replicate biological patterns without biology? Planetary protection agencies are monitoring closely. If collected samples show isotopic ratios matching those detected remotely, refinement will be confirmed. If microstructures align with terrestrial bone mineral exactly, probability calculations will shift further away from chance. Another variable is the object's trajectory after the encounter, 3I. Atlas will continue its path out of the solar system unless additional thrust alters it. Tracking indicates slight, non-gravitational acceleration beyond what outgassing models predict. That anomaly persists. Some theorists suggest the calcium jet is not propulsion, but byproduct. If something at the object's leading edge is interacting with solar wind or interplanetary magnetic fields, the rearward jet may be waste. That would explain the momentum contradiction. However, this hypothesis remains speculative. The broader implication extends beyond immediate science. If matter can be modulated at a universal frequency and directed toward planetary orbits, then communication may not be limited to electromagnetic waves. Material signaling, encoded within isotopic ratios or crystalline patterns, could represent a different channel entirely. Human technology has barely begun exploring matter-based communication. We transmit radio, laser pulses, and neutrinos in theory. But directed mineral dispersal would represent a strategy we have never considered. As data continues to stream in, skepticism remains strong. That is appropriate. Scientific history includes false alarms and misinterpretations. Instrument artifacts, background interference, and statistical anomalies must be ruled out rigorously. So far, triple verification has held. There is also the psychological factor. Interpreting unknown phenomena as intentional carries risk of projection. Patterns can appear meaningful where none exist. That is why teams analyzing the 1,420 MHz modulation are blinded to context, reviewing raw frequency data without knowing its source. In parallel, astrophysicists are revisiting exotic natural explanations. Could unknown plasma interactions produce isotopic separation? Could microscale electromagnetic confinement generate refinement? No current model achieves 99.9% isotopic purity without engineered intervention. The coming atmospheric sampling will provide the first tangible evidence. If Earth passes through the stream and nothing unusual is detected, some anomalies may resolve. If, however, refined calcium 4,0-hydroxyapatite particles are recovered, the interpretation will become far more difficult to dismiss. In 336 hours from the initial announcement, Earth will intersect the projected path. That is less than 2 weeks. Instruments are live. Satellites are tracking. The object continues pulsing with clock-like precision. We are witnessing an event that challenges foundational principles: conservation of energy, conservation of momentum, and assumptions about natural isotopic distribution. Whether the explanation proves mundane or transformative, the data demands attention. And as the hours pass, one reality remains unavoidable. Whatever 3I Atlas is, it is not behaving randomly. The stream is deliberate in direction. The pulses are regulated. The material is specific. The frequency is universal. The evidence is mounting. Now, the countdown enters its final phase. Earth is steadily approaching the projected intersection with the calcium-rich wake of 3I Atlas. Telescopes remain locked, tracking every pulse. The 4-hour and 12-minute rhythm has not deviated. Each burst of ionized calcium 40 continues to accelerate outward at 40 kilometers per second, maintaining alignment with our orbital path. There is no sign of decay in intensity, no drift in frequency. Stability at this scale suggests control, or at minimum, a mechanism far more sophisticated than random sublimation. Atmospheric entry models indicate that most particles will disperse harmlessly in the upper layers of the atmosphere. Yet, harmless does not mean meaningless. Even trace amounts can be captured by high-altitude collection platforms, weather balloons, and orbital satellites equipped with particle analyzers. For the first time in history, humanity may physically sample material that appears refined beyond natural expectation and organized in a structure associated directly with biology. If laboratory results confirm 99.9% isotopic purity of calcium 40 within hydroxyapatite crystals, the implications will be difficult to overstate. Isotopic ratios function as cosmic fingerprints. They reveal origin stories written in nuclear reactions of dying stars. A deviation of this magnitude implies deliberate selection, and deliberate selection implies intent, whether biological or technological. At the same time, alternative explanations continue to be explored. Some plasma physicists argue that unknown electromagnetic confinement processes could theoretically isolate isotopes under rare conditions. Others examine whether quantum-scale interactions with interstellar magnetic fields might produce unexpected ordering of mineral structures. These hypotheses remain mathematically strained, but science demands exhaustive testing before extraordinary conclusions are accepted. There is also the propulsion question. If the visible jet is not pushing the object backward, then something unseen may be pulling it forward. A gravitational interaction with an unseen mass seems unlikely given current mapping of the region. A magnetic coupling with solar wind lacks sufficient strength to explain the acceleration, yet the motion persists, small but measurable, contradicting classical expectations. Another layer of inquiry focuses on information theory. The 1,420 MHz modulation is not just symbolic because of its association with hydrogen, it represents the most abundant element in the universe. Any civilization with basic radio astronomy would identify that line early in its scientific development. Encoding modulation into matter aligned with that frequency could represent a universal handshake, a way of saying, "We understand physics as you do." Still, caution governs official statements. Public briefings emphasize that no threat has been identified and that data collection is ongoing. That is accurate. Fear has no place in analysis, yet neither does complacency. The combination of impossible energy generation, industrial-level isotopic refinement, biological crystalline structure, regulated pulsing, and orbital targeting forms a pattern too consistent to dismiss casually. If the encounter produces ordinary dust with misinterpreted readings, science will correct itself. That is its strength. But if refined hydroxyapatite particles are confirmed, then three possibilities remain. First, unknown natural physics capable of mimicking lifelike structures exists. Second, a technological system is dispersing engineered material across interstellar space. Third, a biological process beyond Earth is interacting with our solar system. Each scenario reshapes humanity's perspective. The first expands physics, the second expands technology, the third expands life itself. As you watch this, the particle stream is crossing millions of kilometers of empty space. In less than 2 weeks, Earth will move through that invisible corridor. Sensors will activate, samples will be sealed, data will flow, and speculation will give way to evidence. For now, we stand at the edge of discovery, guided not by belief, but by measurement. The universe has presented us with a phenomenon that challenges our assumptions at every level. Whether 3I, Atlas proves to be an exotic natural marvel or something far more deliberate, the outcome will echo through science for generations. Stay with this story as it unfolds, because in the next 14 days, we may answer one of the most profound questions ever asked. Are we witnessing a rare cosmic anomaly, or the first tangible sign that we are not alone? If you want to follow every update, every breakthrough, and every revelation as the data comes in, make sure you subscribe, turn on notifications, and stay connected, because this discovery is just beginning.